This is Algebra 2 in our prerequisite chapter, and today we will be reviewing simplifying expressions. So to simplify expressions, you need to combine all your like terms together and also think about order of operations. Here, notice that the only thing that is going on is we are adding and subtracting. So we can add and subtract from left to right, and we want to combine our like terms together. So we have 10a minus 16b plus 7a plus 9b. Our like terms here would be the 10a plus the 7a, which would give us 17a. And then we have a negative or a minus 16b plus a 9b. And so we have to take a negative 16 plus 9, which gives us a negative 7. So this would be minus 7b. So our final answer here would be 17a minus 7b for simplifying. And that would be as simplified as we can go because a and b are not like terms, so we cannot combine them together. Second example, 2 times the quantity 5m plus n minus 3 times the quantity 2m minus 4n. Now here when you think about order of operations, parentheses always comes first. But inside these parentheses, they are not like terms, so we cannot do anything there. There are no exponents, so then we go to multiplication. Whenever you have a number in front of the parentheses, recall that that is like a multiplication. So we will need to distribute the 2 throughout the parentheses and distribute the minus 3 throughout the parentheses. So 2 times 5m is 10m. 2 times n is 2n, so we have 10m plus 2m, 2n. Now here when we distribute this, we have to make sure we distribute a minus 3. Because when we have a minus 3 and then parentheses, it's like adding a negative 3. So we have to make sure we distribute that negative 3 throughout those parentheses. So negative 3 times 2m is a negative 6m. Negative 3 times a minus 4n would be a positive 12n. And then from here, we can now go left to right and combine like terms. So we have 10m minus 6m for like terms would be 4m. And then here we have a plus 2n and a plus 12n for like terms would be plus a 14n. So here our final solution would be 4m plus 14n. Okay, so next example. Here we have 5 halves times the quantity 6x minus 4y minus 2/3 times the quantity 4x plus 8y. This problem is really the exact same one as our previous problem. The only difference is here we have fractions instead of integers in front of our parentheses that we have to distribute. So here we'll have to take 5 halves times our 6x minus 4y and negative 2/3 times our 4x plus 8y. Well, 5 halves times 6. I know some of you out there will struggle a little bit with fractions, so I'll write this out so we can see it. Recall when you multiply fractions together, you would want to simplify numerators and denominators. So we can do 6 divided by 2 first. 6 divided by 2 is 3. So it changes to a 3 and a 1. So we really have 5 times 3 left, which is 15x. Same idea, 5 halves times 4. Well, you can do the 4 divided by 2 first to get 2. You really have 5 times 2 left, which is 10. So when you distribute 5 halves through, you really have 15x minus 10y. Okay. Now 2/3, we can do the same exact idea here for 2/3. When we take 2/3 times 4, notice that nothing actually simplifies here, top and bottom. So you just multiply straight across. So 4 times 2 is 8. 3 times 1 is 3, so that's 8/3. So we'd have minus 8/3 x. And then we have to take 2/3 times our 8 2/3 times 8. Once again, nothing simplifies numerator and denominator, so we have to multiply straight across. 2 times 8 is 16. 3 times 1 is 3, so that's 16/3. And it's a negative 2/3 that we're distributing because of the minus sign, so this would be minus 16/3 y. All right, and then once when you're here, now you need to go through and combine your like terms together. So here we have a 15x minus an 8/3. Now, you can do this however you would like to. Most of the time you're going to need a common denominator to combine these together, but when you do 15x minus 8/3, you get 12 1/3 x. Is perfectly fine if you leave that improper. So if you leave that as 37/3 x, I'm fine with that. So to combine those, you need common denominator. So you want to change the 15 to a denominator of 3. So you have to times 15 by 3, which gives you 45. So you have 45/3 x minus 8/3 x, which is where you would get the 37/3 x or 12 1/3. All right, so now we need to combine our minus 10y and our minus 16/3 y. So here you want to do the same exact thing. When you take a negative 10 and you subtract 16/3, you get a negative 15 1/3 y. Or as improper, it would be 46/3. So 10 you need to write with a denominator of 3. So you have to take the 10 times the 3. So you'd have negative 30/3 minus 16/3, which is how you would get your negative 46/3. Or as a mixed number, negative 15 1/3. So either one of those is acceptable for your simplified solution. Since this started with fractions, though, your solution must have fractions. Recall the only time you can answer in decimals is if you start with decimals. Okay, let's do a few more examples here. Here we have the quantity x plus 5 times the quantity x minus 7. Now notice we have parentheses. We can't simplify within the parentheses. So we move on to the next order of operations, which is exponents. No exponents, so then we multiply. So here we are multiplying between these two parentheses. So we are going to need to distribute both the x throughout and the 5 throughout both of those. Okay? So we are first going to take x times x, which gives you x squared. Then x times minus 7, which is minus 7x. So we distributed the x to both. Now we do the same with the 5. 5 times x, which is plus 5x. And 5 times minus 7, which is negative 35. Combining like terms, we have the x's in common. So we have x squared. Negative 7x plus 5x is a minus 2x, and then minus 35. Some of you may be saying, oh, Ms. Burns, I know a different way how to do this. There is another way that many of you learned, which is called FOIL, which only works. FOILing only works when you have two binomials multiplied by each other. Binomials means that you just have two terms, like x plus y. F stands for the first terms you multiply. O stands for outside. I stands for inside. And L stands for last. It doesn't matter to me if you think of it as distributing or if you think of it as FOIL. Whichever way you understand the best is fine. So if we think of this as FOIL instead of as distributing, we go, okay, we do the first terms. So our two first terms here are x and x. X times x is x squared. Okay, and x is outside. X is on the outside and minus 7 is on the outside. So x times minus 7 is minus 7x. Then you do the inside. 5 is on the inside and x is on the inside. 5 times x is 5x, so plus 5x. Then you do the last. 5 is the last position, negative 7 is the last position. 5 times negative 7 is negative 35. Negative 7x plus 5x like terms. So you have x squared minus 2x minus 35. Notice we get the same exact simplified answer regardless of which method we choose. Either way, whichever method you choose, stick to it throughout the course of this year, and you will eventually be able to jump straight from here to the simplified answer because we will be doing so much of this, you'll be able to do that middle step in your head. All right, one more example like that. The quantity 2x plus 3 times the quantity 3x minus 5. Let's do the distributive method. So I have to take 2x times 3x, which would be 6x squared. 2x times minus 5, which is minus 10x. 3 times 3x, which is plus 9x. 3 times minus 5, which is minus 15. Negative 10x plus 9x are like terms, so 6x minus 15 is our simplified solution. All right, we will run through this once as foiling as well, for those of you who prefer that method. 2x plus 3 times the quantity 3x minus 5. First terms, 2x and 3x is 6x squared. Outside, 2x and negative 5 is a minus 10x. Inside, 3 and 3x is a plus 9x. And last, 3 times negative 5 is negative 15. Like terms are your x's. So you have 6x squared minus x minus 15. All right, just a couple more problems here. Here we have a to the 4th to the 5th power. You're going to have to recall laws of exponents, which we actually were already using in the previous problem. But the two laws of exponents that you're going to need to remember is when we have something raised to a power, so b to the x raised to another power y, that is the same thing as b to the x times y. And if we have b to the x times b to the y, that's the same thing as b to the x plus y. Here, b, our base number, must be the same. In order for this to work when we're multiplying them. So here, if we have a to the 4th raised to the 5th power, that's the same as multiplying your two exponents. 4 times 5 is 20, so this is a to the 20th. The other way you could think about this is you have a to the 4th, so that is 4 a's, just like that, and you have that 5 times. So you have 4 a's, that's 2 times, that's 3 times, that's 4 times, and that's 5 times. You may recall doing stuff like that in Algebra 1. And now you could count up how many total A's you have. There's 4, 8, 12, 16, 20 of them. So there is 20, a to the 20th for 20 A's. All right, next up, a to the 5th times a to the 7th. And it uses this property down here. Same base number, so we just add our exponents. 5 plus 7 is 12, so this is a to the 12th. Or you can think about it as a to the 5th is 5 a's, so there's 5 a's. A to the 7th is 7 a's. And then if you add them all up, 1, 2, 3, 4, 5, plus 6, 7, 8, 9, 10, 11, 12, you get 12 total a's, so you have a to the 12th. Obviously, writing them all out and counting them up is going to get difficult the higher exponents we use. So make sure that you recall these laws of exponents and get used to using them on a regular basis.